Today's lesson is on what is a power. In math, we like to be lazy. Well, not really lazy, but we'd rather be efficient. So if we see something like 2 plus 2 plus 2 plus 2 plus 2 is 10, instead of writing 5 2's down, we write it as 2 times 5 because there's 5 2's being added. So multiplication is a short form for repeated addition. Well, there's a short form for repeated multiplication. Instead of writing 3 times 3 times 3 times 3 is 81, we can use powers. So here, the 3 is repeating. So that is our base. The 4 is how many times it repeats. That's the exponent. The whole thing is called a power. Okay? The whole thing is a power, but the 3 is the base and the 4 is the exponent. And 81 is what it's equivalent to. So that would be standard form. Okay? Now, over here, it just highlights what I mentioned. That 3 is the base and 4 is the exponent. The way I would think about it is 3 is the thing that repeats, and 4 is how many times it repeats. So let's do some examples. State the base and the exponent. Okay. Number 1, what's the base? 2. Very good. And what's the exponent? 8. Awesome. Okay? That's great. That's it for the first one. Okay, next one. What's the base? Very good. What's the exponent? 4. Excellent. We don't have a number 3, but I'm going to make a number 3. Okay, number 3. What's the base? This is a tricky one. The base is just 3. This is not meant to be super obvious. So let me focus in on this.
No brackets?
There's no brackets. If we saw brackets around the -3, then the base would be -3. However, no brackets, then the negative is not included. So the base is just 3. And the exponent, well, the exponent is what? 2. Yeah, that doesn't change. But the base does. So you have to be aware if there's a negative sign, but is it included? And if it's included, it has to be in the brackets. Has to. Now, understanding that exponents are just a short form for repeated multiplication, what number repeats in the next example? 9. 9 would be our base, and our exponent would be how many times it repeats.
5.
It is 5, absolutely. So in exponential form, this would be 9 to the exponent 5. All right, moving on. we're going to write each of these as repeated multiplication. So the first one would be what?
9 times 9 times 9.
Very good. Note it doesn't ask us to figure out the answer. It just says write it as repeated multiplication. So it's just 9 times 9 times 9. Done. Don't have to do anything else with it. Next one, what would it be?
Negative 2 times negative 2 times negative 2 times negative 2.
If we do not put stuff between the brackets, there's like an invisible multiplication sign, even if you don't put stuff in between the brackets. You can put multiplication signs. It's totally cool if you do. But if you don't, it also means multiplication. So negative 2 times negative 2 times negative 2 times negative 2 is how you do that one. And what about number 3?
2 times 2 times 2 times 2.
Yes, the only thing you're missing is the single negative sign. Because the negative is not part of the base, so it's not part of what repeats. But, of course, the 2 does repeat 4 times. So that's why we have to be super aware of whether that negative is part of the base or not. So it's 2 times 2 times 2 times 2 with a single negative sign out in front. Okay? Next example. Predict whether each number is positive or negative, and then evaluate it. Evaluate, great word. And sometimes when people ask me how many languages I speak, I'll say 2, English and math. Math is a language in and of itself. There are certain words that you see that are going to dictate what we do. The word evaluate is one of those words. Evaluate is a fancy way of saying find the answer. Whenever you see the word evaluate, and you're going to see it a lot, not just in grade 9, you'll see it in grade 10, 11, and 12 too. You'll see it everywhere in math. The word evaluate means find the answer. Sometimes when we do this stuff with powers, we will simplify them and then we'll stop. But when it says evaluate, we will simplify them and then we'll figure out what the answer is. So that's what the word evaluate means. So when we look at 4 squared, the first one, do you think that's going to be positive or negative?
Positive.
I agree. And 4 squared is how much?
8.
Nope.
Oh no, 6.
16. You're right, 16. So, yep, it's positive. That's our prediction. And it is positive 16. You bet. Second question. Do we think it's going to be positive or negative?
Positive.
I hear positive and I hear negative. It's going to be negative. Because when we look at this sign, remember, what does that mean? It means it's not part of the base, so it's only going to be a single negative sign. If you only have a single negative sign, the answer is negative, because it's going to be negative, and then it's going to be 3 times 3 times 3 times 3. Well, what is 3 times 3 times 3 times 3? 81. And because there's a negative sign in front of it, it's going to be negative 81. So that one is negative, and it's negative 81 when we evaluate it. Third one, positive or negative? What do you think?
Negative.
Positive.
One of you's right.
Positive.
Is positive. The reason why it's positive is you have negative 5 and you're multiplying it by itself 2 times. And when you multiply 2 negatives together, what do you get?
Positive.
You get positive. And in this case, it's going to be positive what? 25. Very good. The last question is a fun one because we don't see 1, but we see 2 negative signs. And actually, if we write this out as repeated multiplication, we're not going to see 1, we're not going to see 2. How many negative signs will we see?
4.
4. So is this going to be positive or negative?
Positive.
Indeed. You see, if you have 2 negatives, they together make a positive. Then we have another 2 negatives, and they together make a positive. And if you multiply 2 positives together, what do you get?
Positive.
A positive. In a string of negative signs like this, here's what we can do. We can think of it as if there are an odd number of negatives. First of all, what's an odd number? Well, I'm not going to assume you know that. What's an odd number?
One that cannot be divided into 2.
Sure. So give me 5 odd numbers. Go.
1, 3, 5, 7, 9, 11.
Thank you. Okay. Those are odd numbers. When you have an odd number of negatives and they're all multiplied together, your answer is always going to be negative. But when you have an even number of negatives and they're multiplied together, the answer will always be positive. Always. And here, how many negative signs do we have?
4.
Is that odd or even?
Even.
It's even, which is why the answer is positive. And 2 times 2 times 2 is what?
8.
8. So the answer is positive 8. Okay, last example. Here we go. Write each number as a power with base 3. Explain your method. So let me just tell you what we're trying to say here. What we're trying to say is 3 to some exponent is equal to 27. 3 to some exponent gives us 9. 3 to some exponent is 243. What we want to do is figure out the exponent. So 3 to what exponent is 27?
9.
No.
3.
Thank you. Think about it. You have to think of how many times does 3 multiply by itself to get to 27. So 3 times 3 times 3 is
27.
27. How many 3's are there? 1, 2, 3. That's why that's a 3. Three to what exponent is 9?
2.
Correct. Because 3 times 3 is 9. And there are 2 3's being multiplied by one another. And last but not least, what's the exponent for part C?
5.
Correct. Now, what you could do to do this is I would use this right here as our launching off point. You know that 3 3's make 27. Okay, cool. Now I'm going to take 27 And I'm going to multiply that by 3. So that's my fourth 3. What's 27 times 3?
81.
81. Understanding that so far, I've used 1, 2, 3, 4 3s. Now, I'm not quite at 243. Okay, no problem. I'll multiply by another 3. So we'll go 81 times 3. What's 81 times 3?
243.
243. Ding, ding, ding. We got a winner. And it took us 5 3s, which is why the exponent is a 5.